Hi, today we'll be going over number 51 through 60 on the math portion of the 2018-2019 official practice ACT. Starting with number 51, we see the list of numbers 41, 35, 30, x, y, 15 has a median of 25. The mode of the list of numbers is 15. To the nearest whole number, what is the mean of the list? There's a lot going on in this question. First of all, we have to know what median, mean, mode, all of those things mean. So we have our median, mode, and mean. So first we have this list and we know it has a median of 25. There's not a whole lot we can do with that yet, but we then read that the mode of the list is 15, which means 15 is the most frequent number. So we know either x or y is going to have to be 15. So let's just say y is going to be 15. So we can replace y with 15. Now let's rewrite this list of numbers in order from least to greatest. 15, we're going to place x here. Fix 30. So now we know that our median is 25. Median, again, is just the middle number of a set, and that's why I put x here where I put it, because 25 is going to be right in the middle here because we have an even number. It's going to be the average of the two surrounding it. So we can do x plus 30 divided by 2 equals 25. And then we multiply both sides by 2. We get x plus 30 equals 50. Subtract the 30. Then we get x is equal to 20. Now, this is not the answer. This is just the value of x. This is not the mean of the list, which is what this question is asking for. I think these are kind of mean questions, but they ask them frequently, where they try to trick you. So what is the mean of the list? The mean is just the average. So now we can find the average of all our numbers. So we do 15 plus, now instead of x, we know it's 20, plus 30, plus 35, plus 41, divided by the total number of numbers we have, which is 6. And then that is equal to 26. So 26 is our mean, which means our answer to 51 is C. Moving on to number 52. Make this a little smaller. Moving on to number 52, you are given the following system of equations. Y is equal to x squared and rx plus sy is equal to t, where r, s, and t are integers. For which of the following will there be more than one xy solution, with real number coordinates for the system? So anytime you see a system of equations like this, I immediately try to combine them into one. So I have y equal to something already in the top equation, so I'm going to use that and plug everything into this y. So we're going to get rx plus s, one more time, s times x squared is equal to t. So now we have this equation. What now? So I see that we have a quadratic equation. We just have to rearrange it so that one side is equal to 0. The fastest way to do that would be subtracting t from both sides. And then we'll rewrite it as x squared plus sx squared plus r minus t is From here, we can plug this into the quadratic equation or the determinant. So we know that b squared minus 4ac, if we take the square root of that, that's going to tell us how many solutions we're going to have for the system. So we know that our value for b is r, so r squared minus 4 times a, which is s, times c, which is negative g. Let's simplify that to r squared plus 4st. So we see this matches f and k. Now, does that have to be greater than 0 or less than 0? This has to be greater than 0, because if we have a number that's greater than 0, and we take the square root of it, we will have 2 real solutions. If it's less than 0, we won't have any real solutions. So the answer is F, number 52. 53. The third and fourth terms of an arithmetic sequence are 13 and 18 respectively. What is the 50th term of the sequence? So we have 1, 2, 3, 4 terms. And we know the third term is 13, fourth term is 18. So from here to here, we know that we added 5. So to go backwards, we subtract 5. So 13 minus 5 will get 8. 8 minus 5 will get 3. So our first term is 3. Now, arithmetic sequences, we use this formula. A sub n is equal to a sub 1 plus n minus 1 times d. So we're trying to find the 50th term, so n is going to be 50. Our first term, a sub 1, is 3, plus n is 50 again, minus 1 times d, that's our common difference, which in this case is 5. So we add the 5. From here, we just solve. So we get a sub 50 is equal to 3 plus 245. So we know a sub 50 is going to equal 248. So our answer to this question is A. Number 54, one of the following graphs in the standard xy coordinate plane is the graph of y is equal to sine squared x plus cosine squared x over the domain negative pi over 2 is less than or equal to x is less than or equal to pi over 2. Which one? So if we look over here, we'll see the graph of sine squared x in red and cosine squared x in blue. Remember, if you have a graphing calculator, you can definitely use it on this exam, and you could just type this in and see which graph matches the graphs in the answer choices. If you don't have a graphing calculator, you can remember these graphs. So we start at 0 and we go to 1. The cosine graph starts at 1. The sine graph starts at 0. So we see that they are complete opposites of each other. So when the sine squared graph is at 1, the cosine squared graph is at 0. Here they're both at 1/2. Here the cosine squared graph is at 1, and the sine squared graph is at 0. So we end up just averaging it out, and we have a straight line at 1/2. So our answer choices, H, matches that. So the answer to number 54 is H. Number 55, what is the period of the function f of x is equal to cosecant 4x? If we remember our standard equation for trig functions, we know y is equal to a sine of b x minus c plus d. A would be amplitude, b is going to give us the period of the function, but we'll come back to that. C is the horizontal shift, and D is vertical shift. So the period of a function is equal to 2 pi over b. So we're going to use our b value here to determine our period. So what's our b value in this equation? That'd be 4. So our period is equal to 2 pi over 4, which simplifies to pi over 2, which is E. So the answer to number 55 is E. Number 56, at the school carnival, Mike will play a game in which he will toss a penny, a nickel, and a dime at the same time. He will be awarded 3 points for each coin that lands with heads face up. Let the random variable x represent the total number of points awarded on any toss of coins. What is the expected value of x? So we have 4 different possibilities. We have 1 will land on heads, and 2 will land on tails. This could happen a total of 3 different ways. So it could be either the penny, the nickel, or the dime that's heads up, and then the other 2 would be tails. So this is 3 possible times 3 points you would earn from that. Because you have 1 that's heads up, every heads up, face up, would be 3 points. Another possibility is 2 heads and 1 tail. There are again 3 possibilities. The tails could be the penny, the nickel, or the dime, and then the other 2 would be heads. This would give you, instead of 3 points, 6 points, because now 2 are face up. Another possibility, all 3 are heads up, face up. This would give you 9 points, and it would only happen once. Our final possibility is all tails. So 3 tails. This would happen once and would give you 0 points. Now let's multiply all these out. So 3 times 3 is 9. 3 times 6 is 18. 9 times 1 is 9. And 1 times 0 is 0. After adding all of those up, we get 36. And how many different outcomes are there? There are 8 different outcomes. We had 3 here, 3 here, 1 here, 1 here. So 6, 7, 8. 36 divided by 8. That gives us 4.5 or 9 over 2. That matches into choice H. So the answer to 56 is H. Number 57, for what positive real value of k, if any, is the determinant of the matrix equal to k? And then they tell you what the determinant of the matrix equals. So we are just plugging into this equation. So starting with A and D, that's k and k. So we have k times k minus, what's our b? That's 4, times our c, which is 3. And we want to know when the matrix equals k, or the determinant of the matrix equals k. So we can simplify this. So k squared minus 12 equals k. We have a quadratic equation, so we want one side to be equal to 0. So we're going to move everything over to the left. We have k squared minus k minus 12 is equal to 0. From here we can factor, so we end up with k minus 4 times k plus 3 equals 0. And we want a positive real value. So k would be equal to 4 and negative 3, but negative 3 isn't a positive real value, so it has to be 4. So the answer to 57 is B, 4. Number 58. Given a positive integer n such that I to the power of n is equal to 1, which of the following statements about n must be true? So note, I squared is equal to negative 1. So if I squared is equal to negative 1, I to the fourth is equal to positive 1, because it's essentially negative 1 times negative 1. So this would be the case if we did I to the 6th, it would again be equal to negative 1. If we did I to the 8th, it would be equal to positive 1. So when I to the power of n is equal to positive 1, we know that's the case when n is equal to 4 and when n is equal to 8, and that trend would continue each time you go up by 4. So from here, we know they want to know which of the following statements about n must be true. When n is divided by 4, the remainder is, so let's just try 4. 4 divided by 4, that leaves us with 1. 8 divided by 4, that leaves us with 2. We don't have remainders in either of these, and that trend would continue. So we know that when n is divided by 4, the remainder is 0. Number 59. For negative pi over 2 is less than or equal to theta is less than or equal to pi over 2, the absolute value of sine is greater than or equal to 1 is true for all and only the values of theta in which of the following sets. We have our sine graph. It is going to look like this, kind of. And we're only going from negative pi over 2, negative pi over 2, to pi over 2. So we're only looking at this portion of the graph. And if we want to know the absolute value when it's greater than or equal to 1, we know that all of this area in here is going to be less than 1, or closer to 0. Whereas at these two peaks right here, those values are going to equal 1. So we know that the answer is A. And because even this down here is negative 1, we're taking the absolute value of that. So we would include negative pi over 2. So it would not be B, because negative pi over 2 also has to be included. Finally, number 60. Ray PK bisects angle LPM. The measure of angle LPM is 11x, and the measure of LPX is 4x plus 18 degrees. What is the measure of KPM? So we have an angle LPM. And PK bisects that. So right down the middle. The measure of LPM, so this full angle, is 11x. The measure of LPK, so this right here, is equal to 4x plus 18. So if we know that PK bisects this, essentially cuts this angle in half, we know that 2 times 4x plus 18 is going to be equal to the total angle, which is 11x. From here, we can solve for x, so we're going to get 4x plus 18 is equal to 11 over 2x, subtract 4x, 18 is equal to 1.5x. Now you divide by 1.5, x is equal to 12. So the angle is not 12, so do not choose F, even though it's easy to think that you're done once you solve for x. They want to know what the measure of KPM is, so this angle. And we know this angle is the exact same as LPK. So these two are the same. So if we can find LPK, we can find KPM. So let's plug in our X right there. So 4 times 12 plus 18, that will give us 66. So that is our angle measurement, which matches answer choice K. So the answer to number 60 is 66 degrees, or answer choice K. And that concludes the math portion of the 2018-2019 practice ACT. I hope that this was helpful, and best of luck with your studying.